In this video, I will solve this limit here. Okay, so how do we do this? Look at this limit here. What makes it complicated is the exponent x here. So maybe we can try to take the natural log of the limit and then bring the exponent x down to the front here. Right, so that make it easier using the natural log property. Okay, to do that, I have to first let y equals to this whole limit here. Now, take the natural log of both sides. And of course, right, we can switch the limit and the ln, right? In this case, doesn't matter. So let's switch this. Now, we can bring the exponent x to the front here. Now, what should we do next? Let me write this better. Of course, if you try to put infinity into x here, inside the ln, right, you get infinity over infinity plus 1. That doesn't really tell you much, right? But you can rewrite this thing inside. Now think about it like this. Here, x over x plus 1, right? It's also the same as if I just do this. In the numerator, I add 1 and then subtract 1. I'm not changing anything. Divide by x plus 1. Now I can divide this, right? So it will be like this. So that is just x plus 1 over x plus 1 minus 1 over x plus 1. And of course, this is just 1, right? So 1 minus 1 over x plus 1, right? I can rewrite this into here, right? Then if I put the infinity into x here, I have 1 minus 0. I basically get ln of 1. Okay, so let's do this. So that is equal to 1 minus 1 over here, x plus 1, like that, okay? Okay, now still, if I put infinity into x here, so this will become 1, ln of 1 is 0, but if we put infinity here, right, it's 0 times infinity. That may not tell us much either, right? But we can rewrite this, right? Times x is the same as dividing by 1 over x, right? Like this. So it's the same as this. Because dividing by a fraction is multiplying by the inverse of the fraction. Okay, now if you put infinity into x here, you get this, right? Okay, let's do it like this. ln of 1 minus 1 over, now, infinity plus 1 divided by 1 over infinity. And of course, right, this is going to 0, right? So this is just ln of 1. ln of 1 divided by 0. And ln of 1 is 0, so we have 0 over 0. So that's the indeterminate form. What we can do is we can use the L'Hopital's rule on this, right? See what we can get further. Okay, so here, we use the L'Hopital's rule. Take the derivative of the numerator over the derivative of the denominator Okay. Now let's do it here. So the derivative of the numerator. Let's do it here. So how do we do this? Because you can see that this is like a function inside another function, natural log, right, of ln, right? So we can use the chain rule. To do that, I will first let k equals to this function here. Like that. And of course, 1 over x plus 1 is the same as x plus 1 all to the power of minus 1, right? So I can write this. Like that. Now in this case, I will let w equals to the function inside. Then k will become ln of w. Okay, now let's take the derivative of w with respect to x here. Now, derivative of a constant is 0 minus, now bring the exponent to the front, times this. Now, minus 1, so minus 2. Derivative of x plus 1 is just 1. So basically multiply by 1, right? And that would give me, now this is positive 1 times this. So it's 1 over x plus 1 squared, like that. Okay, next, take the derivative of k with respect to w. So we have dk over dw. So that is just 1 over w. And what is w? We set w equal to this, right? So that's the same as 1 over, and this is basically this, right? 1 minus 1 over x plus 1. So I can write this. 1 minus 1 over x plus 1. Okay, now, to find the derivative of this, right? Basically is finding the derivative of dk over dx, right? So dk over dx is equal to dk over dw times dw over dx, right? According to the chain rule. Okay, so dk over dw is this, right? 1 over 1 minus 1 over x plus 1 times dw over dx is this, 1 over x plus 1 squared. Okay, remember this is just equal to x over x plus 1, right? If we just find the common denominator here, and then we just group them together. So we can do this. This is the same as one over x plus 1, right? This one times this 1 over x plus 2. X plus 1 square, I mean. Okay. Now this is the same as x plus 1 over x, right? So we have x plus 1 over x times this. And you can see that this cancels out with one of this. We have 1 over x times x plus 1. Okay? So that's the derivative of this. Now, of course, at the bottom, right? Derivative of 1 over x. Here. That's just equal to derivative of x to the power of negative 1, right? And that is just equal to negative x to the power of negative 2. And that's just equal to 1 over x squared, okay? So this divided by this. So we can write this here. That's equal to limit as x approach infinity. The top here will be 1 over x times x plus 1, right? Divide by 1 over x squared. Like this. Oh, there's a minus sign here. Okay. Just like this here, right? There's a minus sign here. Okay. Now, dividing negative 1 over x squared is the same as multiplying by negative x squared, right? It's the same as this. And one of the x here will cancel out with the x here. Then we have only this left. Right? Okay, of course, if you put infinity into x here, you get infinity over infinity plus 1, but it's a negative sign here. So that does not really tell you much either. Again, we have to rewrite this one into, right, this. Okay, so that's the same as this. And of course, this time there's a negative sign here, so it will be like this. Right? Then we switch the number, right, due to the minus sign here. So it will be like this. Now you can put infinity into x here, right? Okay, so what is that? 1 over infinity plus 1 minus 1. And as you know that, right, this term would approach 0, would go to 0. So we have ln of y equals to 0 minus 1. Ln of y is equal to minus 1. And of course, we have to take the exponential of both sides, right? So I can get y. So y is equal to e to the negative 1. And that's the same as 1 over e. Okay, now what is y? We said y is equal to this original limit here, right? At the beginning. So that means the original limit is equal to 1 over e. Okay, so that's the answer. If you enjoyed this video, please consider liking and subscribing to my channel. Thank you.